Look around you for a moment. The chair you're sitting on feels solid. The floor beneath your feet feels firm and dependable. The walls around you seem dense and immovable. Every object in your daily life gives the same impression. The world appears to be made of solid stuff. But physics tells a completely different story. At the smallest scales of reality, the things we think of as solid are actually almost entirely empty space. Everything around you is made of atoms. Your body, the air, the ground, even distant stars are built from these tiny building blocks. Yet when scientists began studying atoms in detail, they discovered something deeply surprising about their structure. An atom is not a tightly packed ball of matter. Instead, it is mostly void. At the center of every atom lies a tiny nucleus. This nucleus contains nearly all the atom's mass and is made of particles called protons and neutrons. But compared to the size of the entire atom, the nucleus is incredibly small. Surrounding this tiny center is a region where electrons exist, forming what scientists call an electron cloud. These electrons define the outer boundaries of the atom, and they are responsible for most of the interactions between atoms. The distance between the nucleus and these electrons is enormous compared to the nucleus itself. To understand just how empty an atom really is, imagine a simple comparison. If the nucleus of an atom were the size of a small marble placed at the center of a large stadium, the electrons would be moving somewhere near the outer edges of that stadium. The entire space between them would contain almost nothing at all. Now consider what that means for the world around you. Every object you see is made from atoms arranged in enormous numbers, but each one of those atoms is mostly empty space. When you combine trillions upon trillions of them together, the result still contains far more emptiness than actual matter. Even your own body is built this way. Your bones, your skin, your muscles, and every cell inside you are constructed from atoms whose interiors are almost entirely vacant. Which leads to a strange and fascinating question. If matter is mostly empty space, why does everything feel solid? Why doesn't your hand pass straight through the table when you touch it? If atoms are mostly void, there should be nothing truly blocking them from sliding through one another. And yet, when you press your hand against a wall, it refuses to move any further. Something invisible is stopping it. To understand what that something is, we have to look beyond atoms themselves and examine the invisible forces that surround them. To understand why matter behaves the way it does, we need to look deeper than the simple picture of atoms as tiny particles. Early scientific models often described atoms like miniature solar systems, with electrons orbiting the nucleus, the way planets orbit the sun. It was a helpful idea, but modern physics has revealed that reality is far more subtle. Electrons are not little balls flying in neat circles instead. They exist as spread out clouds of probability. In these clouds, the electron does not have one precise position. Rather, there are regions where it is more likely to be found if measured. These regions form what scientists call an electron cloud surrounding the nucleus. But the most important feature of this cloud is not the particle itself. It is the invisible influence that comes with it. Every electron carries an electric charge, and electric charges produce something called an electric field. An electric field is an invisible region of influence that surrounds a charged particle and affects other charges nearby. You cannot see this field directly, but its effects are everywhere. The electrons in one atom generate electric fields that extend outward into space. The electrons in another atom do the same. When two atoms approach each other, these fields begin to interact long before the atoms ever come close enough for their nuclei to matter. This interaction between fields is what truly governs the structure of matter. As electron clouds move closer together, the electric fields around them begin to push against each other. Because electrons carry the same negative charge, they strongly repel one another. This repulsion happens through the electromagnetic force, one of the fundamental forces of nature. The strength of this force is extraordinary. Compared to gravity, which gently pulls massive objects together, electromagnetic interactions between electrons are enormously powerful at atomic distances. So when two atoms approach each other, something remarkable happens. Their electron clouds begin to resist overlapping. The invisible fields surrounding the electrons push back, preventing the atoms from collapsing into one another. This resistance is not the result of solid surfaces touching. It is the result of electric fields interacting across space. In other words, the boundaries of objects are not defined by solid matter pressing together. They are defined by invisible fields that extend outward from atoms and influence other atoms nearby. This leads to a surprising conclusion. When your hand moves toward a table, the atoms in your skin never actually reach the atoms in the table. Long before that could happen, the electron clouds around those atoms begin pushing against each other. The force becomes stronger and stronger as the atoms get closer. Eventually, that repulsion becomes strong enough to completely stop your hand from moving further. From your perspective, it feels like a solid surface. But in reality, something much stranger is happening. The atoms in your hand are being pushed away by the invisible electric fields surrounding the atoms in the table. Imagine slowly lowering your hand toward a table. At first, nothing seems unusual. Your hand moves through the air easily. There is nothing visibly blocking it. But the moment your skin reaches the surface, the motion suddenly stops. The table pushes back, and the pressure in your hand tells you that you have made contact with something solid. But at the atomic level, the story is very different. Your hand is made of atoms. The table is also made of atoms. Each of those atoms contains a tiny nucleus surrounded by a cloud of electrons. As your hand moves closer to the table, the electron clouds from the atoms in your skin approach the electron clouds from the atoms in the table's surface. Long before the nuclei come anywhere near each other, the electrons begin to interact. Because electrons carry negative electric charge, they strongly repel other electrons. This repulsion is part of the electromagnetic force, one of the most powerful interactions in nature. As the electron clouds move closer together, the repulsive force between them grows stronger and stronger. It is this growing repulsion that stops your hand. Your atoms never actually reach the atoms in the table. Instead, their surrounding electron clouds begin pushing against each other at a distance. The closer the atoms try to move together, the stronger the electromagnetic resistance becomes. Eventually, the force becomes strong enough to balance the motion of your hand. From your perspective, that resistance feels exactly like a solid surface. But there's another quantum rule that makes this barrier even stronger. It is known as the Pauli exclusion principle, first described by the physicist Wolfgang Pauli. This principle states that two electrons cannot occupy the same quantum state at the same time. In simple terms, electrons are forbidden from piling into exactly the same configuration. When atoms are pushed close together, this rule forces electrons to rearrange themselves into higher energy states. That rearrangement requires energy, and the system naturally resists it. The combined effect of electromagnetic repulsion and quantum restrictions creates an incredibly powerful resistance to compression. Atoms maintain their structure, molecules hold their shape, and objects remain stable. This is why solids feel rigid and dependable. Yet the strange truth remains. Even when your hand presses firmly against the table, the atoms inside your hand and the atoms inside the table never truly touch. They remain separated by incredibly tiny distances, held apart by invisible forces acting across empty space. And that realization leads to a deeper shift in perspective. If matter is not held together by solid contact, but by interactions between invisible forces, then perhaps the universe is not really built from objects at all. When we look at the world around us, it feels natural to think in terms of objects. There is a table, a chair, a wall, a planet, a star. Each one seems like a solid thing with clear boundaries separating it from everything else. But when physicists study matter at the smallest scales, this idea begins to dissolve. The deeper we look into atoms, particles, and forces, the less the universe resembles a collection of solid objects. Instead, it begins to look more like a vast network of interactions. What we call matter is not simply stuff packed together. It is a stable arrangement created by forces and energy relationships between particles. Atoms exist because electromagnetic forces hold negatively charged electrons around positively charged nuclei. Molecules form because atoms share or exchange electrons in ways that lower the system's energy. Larger structures, like crystals or living cells, appear when these interactions repeat in stable patterns. In every case, the structure of matter depends on relationships rather than solid contact. Even the particles themselves are better understood as excitations within deeper physical systems. In modern physics, particles are often described as localized disturbances in fields that exist throughout space. The electron, for example, is associated with an underlying electron field that fills the entire universe. When that field vibrates in a certain way, an electron appears. This perspective changes how we think about reality. Instead of imagining a universe built from tiny hard objects, physicists see a universe shaped by interacting fields and energy patterns. Matter becomes something more like a stable configuration within these fields. A useful way to picture it is to imagine waves forming patterns on the surface of water. The waves are not solid objects. They are movements of energy traveling through the water. Yet when the conditions are right, these waves can form recognizable shapes that persist for long periods of time. Atoms and particles behave in a somewhat similar way. They are stable patterns created by the underlying laws of physics. The forces between them maintain those patterns, preventing them from collapsing or drifting apart. As long as the balance of interactions remains intact, the structure continues to exist. This is why the world appears solid and reliable, even though it is built from emptiness and invisible forces. Every object you see is a stable arrangement of atomic interactions maintained by powerful physical laws. The structure feels permanent because those interactions are incredibly consistent. Yet beneath that stability lies an astonishing truth. The universe is not really made of solid things. It is made of relationships between fields, forces, and energy patterns that together create the illusion of solid matter. When you step back and look at the bigger picture, the nature of the physical world becomes deeply strange. Everything around you feels solid, stable, and permanent. You can hold objects in your hands, lean against a wall, or walk across the ground without ever questioning the firmness beneath your feet. Your senses constantly reinforce the idea that matter is made of dense, solid substance. But the deeper physics goes, the more that picture falls apart. Atoms, the building blocks of matter, are mostly empty space. Their tiny nuclei contain nearly all their mass, while electrons occupy vast regions around them in the form of probability clouds. The distance between these components is enormous compared to their actual size. Yet, even those particles are not quite the solid objects we once imagined. Modern physics describes them as excitations of deeper physical fields that extend across all of space. What we call a particle is really a localized ripple in one of these fields, a small packet of energy behaving in a stable way. Matter, in this view, is not a collection of tiny hard balls. It is a pattern. The solidity you feel when you touch something does not come from physical contact between particles. Instead, it comes from the invisible electromagnetic forces between the electron clouds of atoms, combined with quantum rules that prevent those electrons from occupying the same states. Those interactions create resistance, and that resistance is what your nervous system interprets as touch. When your hand presses against a wall, the atoms inside your skin never truly collide with the atoms in the wall. The electron clouds surrounding those atoms repel each other long before any direct contact could occur. You feel pressure, but the atoms remain separated by incredibly small distances. In other words, what feels like touching is actually a powerful interaction between fields acting across space. Once you realize this, the everyday world begins to look a little different. The table beside you is not a solid block of substance. It is an organized arrangement of atoms whose structures are maintained by electromagnetic forces. Your body is built from the same kind of atomic patterns, constantly interacting with the atoms around it. Every object in the universe is part of this vast network of interactions. Stars, planets, rocks, oceans, and living beings all emerge from the same fundamental rules governing particles, fields, and forces. Stability arises when those forces balance in just the right way, creating structures that can last for billions of years. But underneath that stability lies an astonishing simplicity. Reality is not made of solid matter packed together. It is made of energy patterns held in place by invisible forces acting across the emptiness of space. And the next time you place your hand against a wall, remember something remarkable. You are not truly touching it. Your atoms are simply being pushed away by the atoms in the wall, held apart by forces that operate silently within the empty space that makes up almost all of the universe.